Here is a circle of radius 5, and the point 3, 4 sitting on it. Its tangent has a slope, and we are going to find that slope without ever writing y as a function of x. That is a bigger promise than it sounds. Every slope this course has measured began the same way. One input, one output, y written in terms of x. A circle will not do that. Look above 3 on the axis. The curve is there twice, at 4 and at -4, and one formula cannot name both. You can force it. Rearrange, and y is plus or minus the square root of 25 minus x squared. That is two functions, not one, with a sign you must pick by hand before differentiating anything. And at the far right of the circle, at 5, 0, the two halves meet. The tangent there is straight up, so its slope is not a number at all. So here is the question this lesson answers. Can we get the slope straight out of the equation of the curve without solving for y first? Yes, one line, running on the chain rule from lesson 7, covering the whole circle at once. And the answer will hand back something about circles we already knew, which is the best evidence a method can offer. Start by reading the equation differently. X squared plus y squared equals 25 is not a recipe for why it is a sentence, and it stays true at every point of the circle. So walk the point around. X changes, y changes, and the sentence holds the whole way. The left side and the right side are the same quantity at every moment of that walk. And two quantities that are equal at every moment must be changing at the same rate. So differentiate one side, differentiate the other, and set the results equal. Two of the three pieces are easy. The rate of x squared is 2x 25 is a constant, so its rate is 0. Constants do not change. The y squared piece is the interesting one, and it is the whole lesson. Along this curve, y depends on x not by a formula anybody has written down, but it depends on it. Move x and y forced to move with it. So y squared is a function inside a function. Square something, and that something is itself moving. Lesson 7 called that two rates in a row. The outer rate is 2 times the inside. The inner rate is the rate of y itself, which is dy by dx. Multiply them, and the rate of y squared is 2y times dy by dx. Now put the three pieces on one line. 2x plus 2y dy by dx equals 0. And look hard at what that is. An ordinary equation with exactly one unknown in it, and the unknown is the slope. So solve it the way you would solve anything. Take the 2x across, then divide both sides by 2y. dy by dx equals minus x over y, that is the slope of the circle at any point on it, written in terms of where you are standing. At 3, 4 it gives minus 3 over 4, minus 0.75. Now the check, and it is a good one. Draw the radius out to 3, 4. That radius has slope 4 over 3. And minus 3 over 4 is exactly the negative reciprocal of 4 over 3. The tangent is perpendicular to the radius, which every one of us already knew. Nobody told the method. It handed it back. And it does that everywhere. At any point the radius has slope y over x, and the answer is minus x over y perpendicular, all the way round. Now notice what the y in that answer is doing. Above 3 there were 2 points. At 3, 4 the slope is minus 3/4. At 3, minus 4 it is plus 3/4. Same x, opposite slopes. The y is what tells them apart. It is not leftover clutter, it is the address of the point. And at 5, 0 the formula gives minus 5 over 0, which is undefined. That is not the method breaking. That is the method telling you the tangent is vertical, exactly where we said it was. Agreeing with geometry is encouraging. Agreeing with the long way round is proof it is the same mathematics. So take the long way. On the top half of the circle, y is the square root of 25 minus x squared. Differentiate that with the chain rule. The outer function is a square root, The inner function is 25 minus x squared. The outer rate is 1 over twice the square root. The inner rate is minus 2x, multiply them, and the 2's cancel. So dy by dx is minus x, over the square root of 25 minus x squared. And now spot the thing that finishes it. That square root on the bottom is y, so this is minus xxyy, same answer. Both roots are correct, so compare what they cost. One line against 4, with no square root and no sign, picked by hand. And the bottom half came free. Down there y is minus the square root, so the long way needs the whole calculation again. The short way never assumed which half you were on. That is the real point. Implicit differentiation is not a new rule. It is the chain rule, used before the algebra instead of after it. So far the short way has only been faster. Here is a curve where it is the only way. X cubed plus y cubed equals 6xy, the folium of Descartes. A loop through the origin, and two arms running away forever. Try to solve that for y and you are facing a cubic. A formula for it does exist. It runs to several lines, and nobody differentiates it. Differentiate both sides anyway. X cubed gives 3x squared. Y cubed gives 3y squared, times dy by dx, by exactly the same chain rule as before. The right side is a product, 6x times y, so it needs less than 8. That gives 6y plus 6x dy by dx. Now collect. Every term carrying dy by dx goes to one side, everything else to the other. Factor it out, divide, and cancel a 3 from top and bottom. Dy by dx is 2y minus x squared, over y squared minus 2x. The point 3 is on this curve. 27 plus 27 is 54, and 6 times 3 times 3 is 54 as well. So put it in. On top, 6 minus 9 is minus 3. On the bottom, 9 minus 6 is 3. The slope there is minus 1. And minus 1 is right, for a reason you can see without any algebra at all. Swapping x and y leaves this equation unchanged, so the curve is its own mirror image in the line y equals x. The point 3 sits on that mirror, so its tangent must be perpendicular to it, and the perpendicular to a slope of 1 is a slope of minus 1. Twice now, the algebra has handed back a fact the picture already knew. Two traps, and the first one catches almost everybody. Writing the rate of y squared as 2y just 2yy, with no dy dx dx. Watch what that does. 2x plus 2y equals 0. Every rate has vanished, and the thing we were solving for has gone with it. The dy by dx is not decoration. It is the inner rate, and it is the answer. Drop it, and there is nothing left to find. The second trap is a worry rather than a mistake. The answer still has both x and y in it, and that feels like a job left half done. It is not. It takes two coordinates to name a point on this curve, and the slope genuinely differs between them, so both belong in the answer. One last thing, because it is what an exam actually asks for, not the slope, the tangent line. At 3, 4 the slope is minus 3/4. So y minus 4 equals minus 3/4 times x minus 3. Multiply through by 4 and tidy it up. 3x plus 4y equals 25, which is worth a second look. 3 and 4 are the coordinates of the point, and 25 is the radius squared. That pattern holds all the way round the circle. So the move is small, and it is general. If a curve arrives as an equation, differentiate the whole equation. Remember that every y carries a dy by dx and solve. Next lesson, the same move with one change. Differentiate with respect to time instead of x, and this curve becomes a ladder sliding down a wall with a speed for an answer.